All right, so we have some practice questions that I have here. So if you do want to stop your video at this point and try them, and then you can turn it on when you've gone through them just to see how you're doing. Or if you just want to follow along with me, that's fine too. So it says if a seed is planted, it has 90% chance of growing into a healthy plant. If 6 seeds are planted, what is the probability that exactly one doesn't grow? So if I think of the probability, right, so for success, it's saying doesn't grow, so it doesn't grow. So in this case, this 90% chance of growing, this is actually my failure, right? This is 0.9. And so we do have to be careful on how the question is worded. What is our success? What's our failure? So in this case, the probability of success would be 1 minus q, right? Or it'd be 1 minus 0.1. Sorry, 0.9, I'm doing the math in my head, 0.1, right? So the probability of success, it doesn't grow, is 0.1, right, 10%. Now, the number of plants we grow, right, or planted would be 6. So is this a binomial distribution? It should be. We see that there's a fixed number of trials. We see the events should be independent, right? If one plant grows, it shouldn't affect the probability the other one grows. They either grew or they didn't, so there is a probability of success or failure, and the probability of success is the same for all. So it holds true with the 4 criteria from above. So we want to know the probability, right, that exactly one doesn't grow. So x would equal 1. So I'm going to hit my second and distribution. So I get the bars. I'm going to go down to binomial PDF. My trials, so I have 6, right? 6 plants. I have 0.1 for the probability, right, of success that it doesn't grow, and x would be 1 here. And so if we wanted to know the probability that exactly one doesn't grow, it should be 0.3543 for the probability for this one. Okay. So let's take a look at my next practice one. It says, assume that a procedure yields a binomial distribution with a trial repeated n is equal to 5 times. Use some form of technology to find the probability distribution given the probability, right, that p is 0.336 of success on a single trial. So what this wants us to do is just build a binomial probability distribution. Similar to what we did in the last section. That one was just a probability distribution, and this one's specifically a binomial probability distribution. So they told us, right, n was 5, and p was 0.336. Okay. So what this table is saying is when x is 0, right, find when it is, when x is 1 and 2 and so forth, all the way to 5. So we're going to find binomial distribution, right, the probability, basically 6 times because we have the 0 in there. So we're going to hit second and distribution. Go down to binomial PDF. I now have 5 trials. I have a probability of success of 0.336, and my value is 0. Type that in, paste it, and hit enter. So it says 4 decimal places, so 0.1291. Now you can hit the second and bars again to get the distribution. A little shortcut I'll show you is if you hit second and then enter, it will pop up the entry that you have above, and all we need to do is just arrow over and change the x to a 1. So it saves you a little bit of time, not a lot, but so 0.3266 would be the probability for 1. If I do that again, second and enter, and just arrow over so I can hit the 2. Oops, there we go, 2. So 0.3305. And I hit second and entry again, arrow over 2, 3. So 0.1672. Second and enter, arrow over 2, 4. Still 0.0423, and second, the last one, enter, and just go over to 5. So 0.004, let's see, 3. All right, and if you added up the probabilities, right, they should sum to 1 or roughly 1. There could be some rounding errors, but that would be my binomial distribution. Okay. So my last one, right? It says American Airlines flights from Boston to Atlanta are on time 80% of the time. Suppose 8 flights are randomly selected and the number on time flights is recorded. So let's take a look, right? So on time 80% of the time, and then number of on-time flights is recorded. So in this case, probability of success is going to be 0.8, right? N is going to be 8 because we had 8 flights. So the first one says the probability that exactly 3 flights are on time. So the probability that x is equal to 3. We can use the binomial PDF for this one. So we'll hit seconds, we'll hit our distribution, right? To get the distribution, arrow down to binomial PDF. I have 8 trials in this case. My probability of success is 0.8. In this case, x is going to be 3 because we want the 3 flights. So we'll hit paste that. So this probability is 0.009, and it said just 3 decimal places. So 0.009, right? Not a great probability. Now, the next question says the probability that at most 6 flights are on time. So the probability that x is less than or equal to 6. So this can be found on my binomial CDF, right? Because it's a cumulative area. We want all of the probabilities added up for 6, 5, 4, 3, 2, 1, and 0. So we're going to hit seconds and my bars to get my distribution all the way down to binomial CDF now in this case. I still have 8 trials. I have 0.8 as my probability of success. And now I have 6 for the value. I will paste that. And so we find 0.497 for the probability that at most 6 flights are on time, right? Now this one says the probability that at least 3 flights are on time. So the probability of at least would be x is greater than or equal to 3. Now our calculator does not do this, right? It only calculates to the left. So we have to write it as a complement. So the complement would be 1 minus the probability that x is less than or equal to 2, right? This one corresponds to 2, 1, and 0. And this corresponds, right, to basically 3, 4, 5, 6, 7, and 8, right? So if we think about adding all the probabilities together, they'd all be included there and sum to 1. That's why they're complements. So in my calculator, I'm going to do 1 minus my second bars to get my distribution. Go all the way down to binomial CDF. I have the 8 trials. Probability of success is still 0.8. And now my value for x is 2. I'll paste that, hit enter. And so this probability that at least 3 flights are on time is 0.999, right? So a really good chance that at least 3 flights are on time. All right, so I hope you did really well with the practice. Remember, if something, you can always go back and review, rewind, sort of how I entered something on the calculator.